Well, hi there. So in this video, we're going to be taking a look at the very first lecture in the Unit 5 Factor Markets and Market Failures problem set. And so that first lecture is going to get us into the weeds of factor markets. So just as a quick review of like what factors are, first is you should know that there's the three factors of production that we typically consider to be tangible or tradable. If you're tangible, that means that you can touch it. Tradable means you could exchange it. And so we could have a market for them. So we have a market for labor, capital, and land. And just as a quick review of what those do, labor is obviously the workers, right? And then you have the capital, meaning the machines, the tools, and the buildings that are needed to produce objects. And then you have the land, which are the natural resources, and literally the land upon which you construct, say, a factory or a store or something along those lines. And then really there's kind of two outlined ideas here, which is to say what factor supply is and what factor demand is. And I've typed these here so that you really can just kind of spend a moment and kind of try to follow what I'm explaining with these. When you talk about something like factor supply, it's actually coming from individuals, the individual households. When we could write here households that are selling to earn their income. And we learned kind of this basic idea that you have households that sell factors basically to firms. And then firms take those factors, right? Factor demand, they buy those factors in order to make output. And so really the demand here is going to come from firms, and the supply is actually going to come from individuals and households. So it's kind of inverting what we normally think about when we think about demand and supply. In this case, the supply is actually coming from people like you and me who are selling our labor or who have actual ownership of land and capital. And we're selling those things to or renting them to firms who are then going to use those things to produce other things, right? So we often kind of get mixed up in this notion of like who owns which factors. Really, the households, individual, real people own the factors, and they lease them or rent them, or they actually sell them to firms that then use them to make output. Now, in terms of supply itself, if people are more willing to sell whatever that factor is at any given price, then we would say there's more supply. Typically, what we're going to look at when we talk about something like the shifts in supply, it's going to be the shifter of labor. Land, there isn't any shift, right? You can't increase the supply of land. So actually, we would say that land is inelastic. We don't create more land in response to any larger number of product or greater price for the land. It just exists. Capital does have an upward sloping supply curve because people are willing to provide more capital in response to higher prices. Typically, though, we'd say that most of the time you're going to see shifts in terms of supply. It's going to involve shifts of labor. And think about just things that might shift labor in terms of people actually their willingness to work. It's important to note that it's not, right, the wages or the prices of the factors. Just as we learned in kind of Unit 1, when we learned about supply and demand, we said price doesn't shift the curve. We would say that the wages for workers don't change the supply of labor. It just reflects a different price that's paid to that labor. So we'd say the price of labor is wage, the price of capital is rent, the price of land is rent. I've got these abbreviations up here that we'll use later. But basically, we'd say that the thing that's actually going to shift the supply as opposed to the quantity supplied would be things like maybe more babies or more immigrants who are more workers, right? More babies eventually grow up to become more workers. If you have more wealth, that actually means that you have less willingness to work. So for example, if there's a boom in the stock market or house prices are booming, you might actually see fewer people willing to supply their labor in the labor market. Cultural norms can also affect people's willingness to supply labor in the labor market. In many countries around the world today, and in the past in the United States, it was considered culturally unacceptable for women to work outside the home. And so as that shift happened, you had more women entering the workforce in the 1970s and 80s in the United States, you had a greater supply of labor. So again, it's not the actual wages or the prices paid to those factors, it's underlying factors that would cause basically more reasons for them to supply, regardless of what the wage was or regardless of what the price of the factor was. In terms of the demand for factors, this is really going to come from two things, right? One is the price of the output, and two is how much product does the factor actually generate. And so I'm going to try to zoom in and make this a little bit clearer here so you can kind of see what we're talking about. Let me autofocus here. But in short, factor demand is sometimes even just called marginal revenue product. You're going to hear that a lot with factor markets, MRP. It's really an important idea that refers to basically the value of what's being generated by that particular factor. So for example, we would say like the fourth worker at this factory, the marginal revenue product of that fourth worker is say $50. And when we say that the marginal revenue product of that worker is $50, what we're saying is that in the amount of time that that worker was working, they generated a certain amount of output that was worth $50. And so that worker was worth $50 to the company. That's what their marginal revenue product was. The way that we actually define that is just the price of the product times how much the marginal product of that factor generated was. So for example, if a third worker that you hired made 5 units, right, of the paper chains, you could think of it that way, maybe they made 5 paper chains and the price of a paper chain was $3, then the marginal revenue product of that third worker, L3, was $15. And so the two things that would actually shift the demand for an underlying factor for like a worker or for capital or for land would be if the MRP changes. And there are really only two things that can change the MRP, the marginal revenue product. One would be the price of the product itself, because if the price goes up, then there's going to be more demand for the factors that produce that product. So I know that sounds like we're violating the rule of price doesn't shift the curve, but what it's really saying is that the price of the underlying product can affect the demand for the things that produce that product. If it's really, really expensive and much more, much higher price for the product, then the thing that produces it is much more valuable. Whereas if the thing doesn't have a whole high price for the end product, then there's not going to be a lot of wages paid to the workers that are producing that product. The second thing that would affect factor demand is the productivity of the actual factor itself. So the price of the product might stay the same, but if we doubled how many units each worker made, then each worker is literally twice as valuable to the company. So there are two things that could affect factor demand: the productivity of the factor itself, that is to say, how much marginal product do they make, and the actual price of the product that they're producing. Now, we're going to look at like a graphical version of kind of that topic a little bit later. But for right now, we have really two questions that we can answer. One is how much of one factor should we employ? Like how many workers should we hire? And the other is how many of two different factors should we employ? Like how many machines and how many workers should we hire? So I'm going to zoom back out just a shade here and then refocus this, and we'll try to answer that first question. So the first type of question you're likely to get is like, how many should I hire? How many workers should I hire? And so here I've given a table for the quantity of workers and the marginal product of each worker. You can see I've abbreviated MPL. That's a little bit different from what the marginal product is, but it's just really specifying what the marginal product of labor is. How many units did each worker make? So the first worker made 3 units, the second worker made 7, the third worker made 4, the fourth made 2, and the fifth made 1. And you can see that for the first 2 workers, we had increasing marginal returns, and then you had diminishing marginal returns that happened from 2, 3, 4, and on. And probably the 6th worker might even be negative marginal returns. So it connects back to that idea that we learned about with the production function in Unit 3. Now, in order to figure out how many of one we should employ, we need this marginal revenue product, and we actually need the cost of an additional factor, which we call the marginal factor cost. This is the second of the 2 kind of ingredients that we're going to need. So we said really important right up here, the marginal revenue product. The other one that we're going to need is the marginal factor cost. And it's in the name what it is, the additional cost of a factor. So the additional cost of an additional factor. In this context, it's usually just going to be, what did you have to pay that factor? So if the wage rate paid to the workers is $20, that's how much the marginal factor cost is. So we would say the MFC is equal to the wage in these types of markets. We're going to bend the rules later, but for right now, you can just say, well, the additional cost of an additional worker, that's how much money you have to pay them. It's their wage. So firms will hire the inputs up to the point where the marginal revenue product equals the marginal factor cost, or they'll stop before the cost exceeds the revenue product. Once we fill out the table, it might make a little bit more sense what we mean by those. So determine the number of workers to hire with a price of the good, an output price of $20 and a wage rate of 30. So the first worker, the easy column, is going to be the marginal factor cost. The first worker costs us 30. The second worker, the marginal factor cost is 30. It's not saying the total factor cost, that would be the total amount we spent. It's the marginal cost of a worker, which is 30. So 30, 30, 30. Every worker costs the company $30. But the price of the good is 20, so we can figure out how many workers by multiplying the marginal product times that $20. So 3 times 20 is 60, 7 times 20 is 140, 80, 40, and then 20. And now it's a little bit easier to see. This column tells us this is how much money this worker generates for the company. This is how much this worker costs. So the first worker, well, they generate 60 and they only cost 30. We should hire them. The second worker, definitely we should hire them because 140 is way bigger than 30. Third worker, for sure, 80 is bigger than 30. Fourth worker, for sure, 40 is bigger than 30. But we would not hire the fifth worker. And that's because the fifth worker, although they generate money for the company in the amount of $20, they don't generate enough to justify hiring them. So we would say 4 workers should be hired because the last worker's MRP of 40 is greater than or equal to the MFC of 30, while the next worker's MRP of 20 is less than that MFC of 30. And if this seems exactly how we've explained profit maximizing quantity of output, it's exactly the same idea. We're thinking on the margin. Throughout economics and microeconomics especially, we're thinking on marginal analysis, and that's what that is. So if you ever get a question that says explain using marginal analysis, that's what this is referring to. Now let's take a look at the slightly different version of this problem, how many of 2 different inputs to employ. This is called the cost minimizing combination of inputs, and it's very similar to the idea of utility maximization of how many pieces of fudge and cups of coffee should I consume? Or I have this amount of money in my budget, how many apples and how many oranges should I consume? So if you remember that style of problem, it's almost exactly the same idea, just from the perspective of a firm that's hiring workers and machines. So in order to do this, we have to figure out what's their entire budget and find the marginal product divided by the wage equaling to the marginal product divided by the rent. And really, these are just the amount that we spent on that particular machine and that particular worker. And most of the time, the wage and the rent that we paid for the machine is going to be constant, like we were in the previous problem. It's $30 for every single worker. So this would just be over 30 for that problem. So let's take a look at this example. The budget is 18. The wages are 2, the rent is 3. So in order to find these values, we're going to look for where these are equal and get as close as we can where they're equal if they don't. So 1 to 30. So 30 is the marginal product of the first machine. The K here stands for capital. We're not going to use C because we use it for something else later. So that means 30 over 3, because that's the rent, is 10. 60 over 3 is 20. 90 over 3 is 30. 75 over 3 is 25. 45 over 3 is 15. And 15 over 3 is 5. Then we're going to do the same thing on the other side, but with the wage, which is 2. So 10 over 2 is 5. 60 over 2 is 30. Boy, that's a big jump in productivity. 25, 15, 10, and 5. And now we just test the possibilities. Now, I'm always going to tell you, test the middle one first. Or you can start in the kind of bottom and work your way up, whatever order you want to do. But we could see like 10 and 10. Let's test that possibility and see why it's actually not going to be right. 5 workers, well, that would cost us $10. So this 10 is equal to this 10. But one machine, that's only $3. So 3 plus 10 is 13. Our budget is 18. So we can actually hire more workers and more machines and produce more product. So then let's move to the next level. We have a 20, we have a 30 and a 30. Let's test that possibility. Well, 2 workers is going to cost us $4, and 3 machines is going to be 9. So again, that's not going to be 18. We could produce more units. Let's try another one, 25 and 25. So 3 workers and 4 machines. 3 workers is going to be $8, or 3 workers is $6. Whoops. 3 workers, $6. 4 machines, 4 times 3 is 12. 12 plus 6, that's 18. That's our budget. So that means our correct combination is 3 workers and 4 machines. And so we'd say 3 labor and 4 capital because, and we need to explain with numbers, because 25, which is the marginal product of capital divided by the rent, is equal to 25, which is the marginal product of labor divided by the wage. And so what we're doing here, and we can also write, and used the whole budget. What we're doing here is telling the grader, hey, we do know how to compare these columns. And in fact, with $18, the largest amount of product that you would get is 125. If you added this, or sorry, not 125, but if you added like all of the marginal products together and all of these marginal products together, you sum them all together, that's actually the most you could get with the $18. Much harder to do it with brute force than because you'd have to test a huge number of combinations. So 3 labor, 4 capital, because these two are equal at that point. We use the little budget. So hopefully this gives you a good introduction to factor markets. I'll see you next time.